All right, ladies and gentlemen, last class we talked about rotating an object on itself. And today what we're going to be talking about is actually rotating on the coordinate plane. So make sure you have your notes out. The notes page should be, it is page 28 in your binder. First of all, what is a rotation? So the definition is just turning a figure about a fixed point. And in this case, the fixed point we're going to be talking about is the point 0, 0, otherwise known as the origin. Okay. Now, a rotation, what's key to remember is that you're going to be making a circle, and the distance from the center to any point on the shape is going to remain the same. Okay. And then every point is going to make a circle around the center. And once again, the center that we're going to be talking about is the origin 0, 0. We need to know that a rotation is different from a reflection. Remember, a reflection has a line of reflection that you reflect over and it flips. And a translation is when you slide an object from one part on the grid to another. Now we have to know that a rotation is going to be a turn. And when you are turning around a circle. And so there are two D's of rotations. One is direction. On Friday, we talked about two different directions. You can go clockwise, in the clockwise direction, or of course you can go counterclockwise, and that's against the clock. And then the other D I want you to think about is, it's not going to be distance, but when you're turning, we talked about the different degrees of rotation. And so number 2 is going to be degrees. And on Friday, we talked about 4 different degrees of rotation. We've got a 90-degree clockwise. We've got a 90-degree counterclockwise. So I'll call this clockwise, and I'll call this counterclockwise. We've got a 180, which is a full turnaround, and then a 360, which puts you back where you started from. This is not in your notes, but let's go ahead and make a mental note of this. Do you remember the quadrant? So once again, this is our center point, the origin, and we are going to be making turns around the origin. So we can make a 90-degree turn, a 180-degree turn, a 270-degree turn, and back on itself, which would be a 360-degree turn, put us back on itself. So the key to remember is that in each quadrant, so this is quadrant 1, and please remember that both X and Y are positive in quadrant 1. In quadrant 2, the X coordinate is going to be negative, and the Y coordinate is going to be positive. In quadrant 3, you should always end up with both your X and your Y being negative. And if you were to rotate back to quadrant 4, please remember that your X coordinates are going to be positive, but your Y coordinates are going to be negative. And that's going to be helpful when we are talking about rotating an object around the origin, so that you can check to make sure that your coordinates have the correct sign. All right, let's go back to taking notes again. First, we're going to rotate a triangle 90 degrees clockwise. Okay? So let's look at the clock if we need to, and think about the direction that clockwise is going. And in this case, we're going to be rotating counter the way the clock rotates. And so I always like to draw a little arrow to help me out. So counterclockwise, I know it's going to go this direction against the clock. All right, so let's go ahead and take a look. If you need to, you may use patty paper. When you are using your patty paper, you not only want to trace the figure, so you can go ahead and trace the figure on your patty paper, and you're going to label your points A, B, and C, but also please put a little cross where the origin is, and that's going to help us when we're doing our rotation. Now you're going to take your patty paper, and you are going to rotate it 90 degrees counterclockwise. So you're going to rotate it this way. Okay, so remember that. And then you're going to see where the new shape is. I want it to take everything. Okay, so this and this. I figured out how to do it now. So we're going to do a 90-degree rotation. Again, please note, when you're rotating with your patty paper, you want to make sure you turn the object, and then you've got to line it back up with the grid, okay, so that the X mark is in the grid. Now let's look at our new coordinates. So this is going to be C prime. This over here is A prime, and here we've got B prime. So let's compare what happened to our coordinates so that we can come up with a rule for when we rotate triangle ABC 90 degrees counterclockwise, what's going to happen to our coordinates every time. So let's first look at A. And the coordinates of A are 1, 4. The coordinates of A prime now are at -4, 1. Huh. What happened? Looks like they flip-flopped and the 4 became negative. Let's see if that same thing happens for B. So the coordinates for B are at 5. Let's see, you start here, you go 1, 2, 3, 4, 5, up 2. So the coordinates for B are 5, 2. So I'm going to predict that my new coordinates for B are going to be at -2, 5. Let's see if that's true. So I'm going to start here. Sure enough, 1, 1, 2, and up 1, 2, 3, 4, 5. There it is. Huh. And now C, my coordinates for C were at 0, 2, 0. And I'm going to predict my new coordinates are going to be at 0, well, -0, but obviously 0 can't be negative, 2. And sure enough, 0 is here, up 2, and that's where C is. So now I can generalize. I can say that, oh, it's kind of interesting, 90-degree weather, one way to think about this, in 90-degree weather, I wear flip-flops. And I now notice that my X and my Y coordinate have flip-flop positions. So the first thing that I notice happens when I do a 90-degree counterclockwise turn is my Y now becomes my X, and my X is now in my Y position. So they flip-flop. And then the second thing I notice is that this particular coordinate changed sign. In the original problem, it was positive, and it changed to a negative. And here this 2 was positive, and it changed to a negative. So I can also make the adjustment that the coordinate that's on the left is going to change sign. So for a 90 degrees counterclockwise rotation, I can say that the coordinate points are going to flip-flop, 90-degree weather, flip-flop shoes, and I can say that they are going to, the one on the left is going to change sign. Let's make a similar observation for this graph here. This time we're going to do a 180-degree turn. So once again, please take your patty paper out if you need it, and we're going to go ahead and trace our figure and go ahead and trace the axis. Once again, let's see if I can get this to work. Yep, it will work. I'm going to do a 180-degree turn now. And so what I know is that one turn is going to be 90, and then I got to turn it again to hit 180. And once again, I'm going to slide my graph so that they line up on each other at the origin. Now I'm going to label my points. I know this is point C. This is point A prime. Remember, the image needs that prime symbol or that little tick mark. So there's A, B, C. And now let's see what happens to the coordinates when we rotate 180 degrees. So first I'm going to write the coordinates for A. And once again, A is at 1, 4. B was at 5, 2. And C was at 2, 0. And what I notice is that my new coordinates for A is now gone to -1, -4, B has now gone from 1, 2, 3, 4, 5, 1, 2, -5, -2. And C is at -2, 0. Interesting. So what I notice is that, I guess in 180-degree weather, you can't really wear flip-flops because I think you'd probably be dead. So no flip-flopping in 180-degree weather, but what does change is the sign. I notice that over here, both the 1 and the 4 are positive, and then both those signs change to negative on this side. And I notice the same thing happened with point B. Both of the signs changed to negative. And then again, point C, we had a +2 and it changed to a -2. Obviously, 0 is 0. There is no negative and positive 0, so it just stayed the same. So the rule I can come up with for a 180-degree turn, and again, it doesn't matter if you turn clockwise or counterclockwise, you're still going to end up making 2 turns and end up completely turned around. So the rule I can come up with is you don't flip-flop the coordinates, they stay, but what changes is the sign. Doesn't mean they both become negative all the time. It just means that the sign changes. At this time, you're going to want to pause the video and try these 3 problems on your own using the rules we just learned. All right, welcome back. Number 1, what you should have noticed is a 90-degree counterclockwise. It's going to flip-flop in 90-degree weather, and the 1 on the left changes sign. A 180-degree rotation, both coordinates are going to change sign. So the 5 is going to become positive, and the 4 is going to become negative. And then finally, for the 90-degree clockwise, the coordinates, again, it's 90-degree weather, so they're going to flip-flop. And because it's clockwise, the 1 on the right is going to go negative. So this is what your homework is going to look like. You're going to have to, 1, be able to write the rule and then use the rule to draw the new rotation. And so what I like to do first is choose 2 points on my homework, and I'm going to look at Z here, and Z prime right here, okay? And please remember that you always go from the image, the pre-image to the image, excuse me. So from Z to Z prime, all right? And what do I notice about Z? My coordinates are at -3, 1, 2, 3, 4, -3, 4. And my coordinates for Z prime, I'm predicting are going to be at -4, -3. Let's see, 1, 2, 3, 4, 1, 2, 3. So it's at -4, -3. What I notice is that this coordinate stayed the same, but the 1 on the left changed. They flip-flopped, the 1 on the left changed. So this is a 90-degree counterclockwise turn. And the rule is they flip-flop, and the y becomes negative. All right. For number 2, I'm noticing that this is going to be a rotation. It is not a reflection. And the reason I know it's not a reflection is because this coordinate and this coordinate are not the same. If this was a reflection, these would both be w's. And what I can see is that we've got point T and T. So we're going to go from T to T prime. The coordinates for T are 1, 1. The coordinates for T prime are -1, -1, and I can say that this is a 180-degree rotation. The rule is -x, -y. So that's what's going to be required on the homework.